Okay, oh, once again, I didn't answer all of the questions to this. I just remembered, so let's go back and see what they wanted. They wanted me to state the transformations. These are the transformations. They wanted me to sketch the graph for one cycle. I sketched the graph for one cycle. They want me to determine the period. The period hasn't changed. We've gone from negative 60 up to 300. That is still a period of 360 degrees. So we have a period of 360 degrees. That has not changed. Next, they want a domain. Well, the domain goes from negative 60 to 300. So the x values go anywhere from 300 to negative 60. We can see that really easy here. Range. Well, for the blue one, I go down to negative 2, but I go up to 0. So your range is... Let's see what's next. Equation of the horizontal axes. Well, we've done that already. Y equals negative 1. Yay, I've done everything now. Okay, so... Oh, wait. Phase shift. Oh, I missed so much. Okay, phase shift. Well, the phase shift is here. We've said it already, so I don't think I really need to say it again. And the amplitude, well, the A value is 1 unit. This counts as your amplitude. And again, we can see the amplitude here and here. And remember, we're dealing with that final curve. Okie dokie, last one. Exciting. So let's state the transformations. I have a negative, so there is a reflection in the x-axis. There's a 3 there, so there's going to be a vertical stretch by a multiple of 3. So what's that going to do? That means my amplitude's going to be 3. It's going to go up to 3 and down to negative 3. If it was just the sine curve. Now it's also going to move a little bit more. The phase shift, there's nothing inside with the x. So there is no phase shift. None. But we do have a vertical shift up 5 units. Yay! Okay, so how am I going to do this one? Let's do it with point notation first. So point notation is x comma sine x, and it's going to be going to, well, let's see here. There's no horizontal shift, so my x is going to stay the same. I am going to be multiplying the sine x by negative 3, and I'm going to be adding 5. So everything that's changing here is changing in the y. So this will be 0, 0, 90, 1, 180, 0, 270, negative 1, 360, 0. That's your normal sine curve. So we'll be going to 0, 5. We'll be going to 90, 2. We'll be going to 180, 5. We'll be going to 270, 8. And we'll be going to 360, 5. Just to show you that this is a really nice method. There's nothing wrong with this method. We're going to take these points and we're going to plot them now. So I need to go 30, 60, 90. It's just easy. 30, 60, 90. 30, 60, 90. 30, 60, 90. 1, 2, 3, 4, 5, 6. Negative 1, negative 2. Negative 3, negative 4, negative 5. And this is not going to work because I need to go all the way up to 8, right? My highest is 8, so that was a bad scale. So I can either go back and fix it, or I can extend it. And I'm thinking extending it's a bit easier right now. So we'll go up to 8. So I'm going to plot these 1, 2, 3, 4, 5 points, and I'll be done. So 0, 5. Boom, chakalaka laka. 90, 2. Boom, chakalaka laka. 180, 5. Boom. 270, 8. Boom. 360 comma 5. Boom. Where did the horizontal axis go? Well, it went from y equals 0, got moved up 5. Sound effects are extra. Here it is. Whee! Y equals 5. And we're going to sketch the graph. Whee! 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 Yes, the nice wheeze matter. You got to get that in there. And that's your curve. And you're done. You don't have to do the other two. We can answer all the questions that we need to answer. So what's the period? Well, the period's going from 0 to 360. So the period is 360 degrees. What's the domain? Domain is going from 0 to 360. What's the range? The lowest one in the range is 2. The highest one in the range is 8. Amplitude. Well, we can read the amplitude right here. It's going to be the absolute value of -3, which is 3 units. Or we can read the amplitude here. 3 units. Phase shift, none. It's not moved left or right. I'm done. I've done it. Yay! Okay, so what I have for you is a little bit of a summary of what we were looking at here. I don't like, not happy with how they've done this. Let's get rid of that. We talked about the domain a little bit differently, so we'll leave that out. The domain for all of ours is depending where it's starting and stopping for one wavelength. All the rest is good. It's a little bit of a summary if you want to use it. And your homework is going to be some sheets that have been posted to the LMS. You need to download them, and you can work on those questions. And remember, you can always check your answers using Desmos. Okay, kids, we'll talk to you soon.